Let's go ahead and move on then. We'll go to the next page and we'll talk about a different transformation now. Very important. So this one, we're going to start changing the period, okay? So all the periods so far have been 2 pi, but now that's going to change, and it's going to be changed based on this formula right here. I mentioned it on our part 1, but there it is again. Period is 2 pi over k. What's k? Well, k is the number that's multiplying by x inside of the sine or cosine there, all right? All right, so we can see on this one that our k value is 2, which means our period is 2 pi over 2, because it's 2 pi over k. Sometimes that will reduce, sometimes it will not. In this case, it does. And so that's going to reduce to just pi. So the period length of pi, what that means is on this one, we can see we start kind of at the origin there. And then we do 1 hill and 1 valley. And then we finish the cycle at pi radians instead of 2 pi radians. All right, so then our next one here, we have y equals sine of 1/2 x. So in this case, our k value is 1/2, which means our period is 2 pi over 1/2. And so for dividing fractions, I've always told you to multiply by their reciprocal. So I would multiply by 2 over 1. And we get our period as 4 pi. So I think an important distinction there between those two, I'm glad that they put them back to back. So if your k value is greater than 1, it actually shrinks the period. So if your k value is 2 or 3 or 4, your period is going to be less than 2 pi, which 2 pi is kind of the standard one. If your k value is less than 1, so 1/2, 1/3, something like that, it's actually going to increase the period length, okay? So on this one, we can see the period length from 0, we do starting at 0, 1 hill, 1 valley, and then finish the period over there at 4 pi. So that's how we can kind of see that period length is a horizontal distance, okay? Amplitude's really kind of a vertical distance. We talked about that in part 1. So then period is a horizontal distance. So they graphed those 3 all together here. So we have the red graph, or sorry, let's do the black graph is the standard one. So that's sine of x. So that goes, that's 2 pi for the period it finishes. The sine of 2x we just saw cuts that in half. The 1/2 x actually doubles the length, and then the 1/3 actually triples the length from 2 pi all the way to 6 pi. All right. Okay. So now let's apply this. Actually, let's apply this in a second. Before we do, I'd like to make a chart over here on the left, right here. I'd like you guys to make this chart along with me. I think it's going to be really helpful as we move forward here. So it's going to have 4 boxes in it. And I'm going to keep referencing this chart throughout the day. So yeah, please get it over here. Okay, so we're going to look at what do these graphs look like, sine versus cosine. And then what do these graphs look like, positive versus negative? And that's going to give us 4 different looking graphs here, okay? So when sine is positive, we talked about it starts at a midpoint, 1 hill, 1 valley, and then finishes at a midpoint, right? When sine is negative, it still starts at the midpoint, just that it does the hill first and then the valley. When cosine is positive, we said that it starts at the high point and then finishes at another high point. And then when cosine is negative, it starts at a low point and then finishes at a low point. So those are our 4 graphs there, okay? So I'm always going to be keeping those in mind when I draw each graph. All right, so let's do A first. So A is that function there, y equals 4 times cosine of 3x. It first asks me to identify the amplitude and the period. So the amplitude we learned in part 1 is just based on the number in front there. So the amplitude is going to be 4. As long as that number out front is multiplying, which you can see that 4 is multiplying in front. We have a k value of 3 here, which means our period is 2 pi over k, which will be 2 pi over 3. In this case, looks like that does not reduce, so I'll just leave it like that. All right, so you will have some questions on WebAssign that they will ask you to pick the graphs out of a multiple choice, and then they'll also ask you to type in the numbers for the amplitude and the period, okay? Which, you know, you could say that that's not fun, but remember, you since that's different parts of a question, you do get points for each part of the question, right? So just for putting in the amplitude is 4, which I think is really easy, you get a point on that, and you're a point closer to your 90%, right? So that's not too bad. Okay, so let's do the graph, but actually before we do the graph, I'm gonna be kind of identifying which one of these 4 from my chart it is. So for A, I'm gonna say that it's a positive cosine graph. So when I'm drawing the graph, it's gonna look like a positive cosine. Why would I say it's a positive cosine? Well, first of all, it says the word cosine, right? So if it says the word cosine or cos, which I don't like it when people say that, but I say cosine, all right? It's abbreviation, I know. But when it says that, you know it's talking about cosine. And then for positive versus negative, you're really looking at A. You're looking at that number out front, okay? So if that's positive, we're talking positive. If it's negative, we're talking negative, okay? So what I'm going to do is I'm actually just going to copy that cosine graph over here. I'm just going to redraw it exactly as is. You can see I didn't really change anything, correct? So how am I gonna take into account the amplitude and the period on this? Well, what I'm gonna do is I'm gonna do that by labeling, okay? So the amplitude is 4, which means this needs to go up 1, 2, 3, 4. So just by labeling that as a 4, that gives me my amplitude of 4. If my amplitude was 3, I would have just kind of drawn 2 lines in between, and that would have been number 3, right? So you can label it whatever you want, right? Honestly, you don't even really need these lines in between if you don't want to put those. Not necessary, okay? If you just want to draw at the top there and draw 4, that's fine. Okay, and then for period, that's really kind of the same idea except horizontally. So if the period is 2 pi over 3, that tells me that this last line here where we finished was 2 pi over 3. So once again, like when you're going to be answering questions like this, you're not actually drawing it. You are picking the correct graph out of multiple choices, right? So if you have a graph that looks like this, where that 4 and that 2 pi over 3 are labeled as such, and you can see where the high points are, at 0, 4 and at 2 pi over 3, 4, you're going to be able to pick the correct graph. And that's what we're looking for here, right? Okay, so it doesn't need to be like a work of art here or anything. We're just kind of drawing a basic sketch, labeling important points so we can pick the correct graph, okay? Trust me, if this was an art competition, I'm fairly certain I would come in dead last out of everyone in this class because I have opposite of artistic ability, okay? So that's not really what we're going for here, okay? Awesome. All right, so let's take a look at B then. So we're pretty much, or we are done with A, so let's take a look at B. So first of all, the amplitude for B. This is kind of a trick question. So the amplitude for B is 2, okay? Remember, amplitude is the absolute value of A. Amplitude must be positive. The fact that 2 out front is negative is significant. It means that when I graph this, I'm going to be graphing this as a negative sign on my chart instead of a positive sign. I am doing sign now because it says the word sign in there, but it is going to be a negative sign because we have a negative number out front this time. So that's how the negative and the 2 kind of get incorporated into the graph. It's kind of separate, okay? The amplitude is 2, but the shape will be a negative sign instead of a positive sign. Next up, we'll do the period. So we do have a K value here of 1/2. Now, if you are thinking right now, hey, Mr. Barry, I already, okay, so we're going to do 2 pi over 1/2, 2 pi over K. I already did that on the previous page or on the top of this page. I can't even remember. And it came out to 4 pi. Do I have to do it again? I would say no, okay? You are allowed to kind of copy off your own paper, right? But I'll go ahead and do it again, just in case you missed it. So 2 pi over 1, and instead of dividing by 1/2, we're actually multiplying by 2, so that's going to be 4 pi. All right, so I think we have all the info we need. So we'll just go ahead and graph the negative sign. So I'm going to go over to my chart here, sign negative. It starts right here. Looks like this. And now I just take the amplitude and the period into account by labeling, right? So the amplitude means that it goes up to +2 at the high point. It does also mean that it goes down to -2 at the low point. So if you'd like to draw that, you certainly can. And then the period is 4 pi means our last point is going to be the x value of 4 pi. There's usually 3 lines in between the first x value and the last x value. So if you'd like to draw those, you can. It's probably not necessary, honestly. But sometimes it's really easy to figure them out. Like on this one, you can see the 4th line is 4 pi. So then this line would be like pi, and then 2 pi, and then 3 pi, right? That's kind of math you need to know if you want to work at Marie calendars. Pi, 2 pi, 3 pi, 4 pi. Boom, get it? Thank you. Someone in here is laughing because Marie Callender's is famous for selling pies. So if you worked there, you'd have to count a lot of pies. It's a different pie though, it's PIE. It's like a baked dessert, not 3.1415. Okay, let's move on. All right, so now we got one more transformation to look at here, and that is horizontal shifts on the next page. Okay, so horizontal shifts, we mentioned this at the beginning of this section in part 1 on Friday, but a horizontal shift is adding or subtracting inside the sine or cosine. Remember, if it's adding or subtracting outside the sine or cosine, that is an up-down shift. If it's adding or subtracting inside the sine or cosine, that's a left-right shift. And also remember that these are counterintuitive. So this one that says x minus pi over 3 actually shifts it to the right pi over 3. And then this one that's plus pi over 6 actually shifts it to the left pi over 6. Okay. So why don't we do this? You don't have to graph this, but I want you guys to follow the instructions on this practice problem for this function. Let's see if we can write down the amplitude, the period, and the horizontal shift, okay? So let's identify those three things. Ready, go. You have this one? Oh, you want it? Sorry. On page 4. No, 5. All right, listos. Let's go over it. So I got amplitude is 3. I got period is 2 pi over 2, which would reduce to pi. We have a k value of 2 right there. Is that 2 multiplying by x? I'm going to argue yes, okay? Now it's like factored out front here, correct? But I could just as easily distribute that 2 in there and it would be multiplying by x. Okay, then we have a horizontal shift to the right, pi over 4. So for your horizontal shift, if you said to the right pi over 4, you know what you are? You are right. Haha, I get it. All right. So we're going to go ahead and graph this now. Oh, actually, before we do, though, I'm going to identify which one of this is out of my chart, right? So I'm going to say that this is a positive sine graph. So I'm just going to refresh myself over here. What did my positive sine graph look like? Oh, yeah, that was one that starts at the midpoint, hill, then a valley, then finishes at the midpoint, correct? Okay. But ten cuidado, which means have caution, because this is going to look a little different when we start to have our left and right shift. So let me show you this, okay? So when I draw this one, I'm going to start it right here. I'm going to label this as pi over 4, and that's going to be my starting spot. And that's the whole deal with the left-right shift, okay? We've kind of been starting all of these on the y-axis, either at the origin for sine or sometimes a little above or below for cosine, but it's always been on the y-axis. Now it's moving left or right where we start, okay? So I'm going to start there. Then I'm going to do my hill and my valley and stop. So that is me taking care of the horizontal shift to the right, pi over 4, okay? Now on my graph, I need to show the amplitude and the period. So just like before, I'm going to show those by labels. So I'm just going to throw a line up here and put 3. And then I'll throw a line down there and put -3, showing that amplitude going up to 3 and down to -3, all right? Now, the period is going to be a little tougher on this one as well. So let me explain that one in 10 seconds in case anybody's still getting caught up. So I'm going to have to label this last point here. Okay. Now before, if I was doing it the way I said before, we would just label it pi because the period is pi long, but it's not pi here, okay? Because before we were starting at 0. So if you're starting at 0, then whatever the period length is, that's where you finish. But if we're not starting at 0, we need to kind of visualize that this length right here is the period, which is pi. So the horizontal distance from the start to the end of that cycle right there is the period, and so that's supposed to be pi. And so if you want to find that last point when you have a left-right shift, the best way to find that last point is to do where did you start plus what's the period length? So when we were starting at 0, obviously we just used the period length because 0 plus anything is the thing, right? Is the other thing. But if we're starting at pi over 4, we need to use that to add to pi to get the last point. I'm sure I don't need to tell you guys that if we're going to add fractions, we need a common denominator. So we get pi over 4 plus 4 pi over 4. So that's obviously 5 pi over 4. So that's our end point. That's from adding. So I started at pi over 4. I added the period length. So the period length was pi. Convert that to 4 pi over 4 as a common denominator. Add them together. That gives you that end point. Awesome. All right, we'll do this again here on the next question. Now, the next question before we start, I don't like how this one's written, but they write it like this a lot. So I don't like this 2 in there multiplying by the x. So I want to factor it. I want to take that and I want to factor it out front. So what that's going to look like is this. Y equals 3/4 cosine 2, and then open up a parentheses. So we're taking that 2 from the 2x. We're pulling it in front of that parentheses, but still after the cosine, right? And then, so if I have 2x and I take out a 2, obviously I'm just left with x, correct? That one's pretty easy. This is like reverse distributive property. Okay, what's tougher though is the 2 pi over 3. What does that turn into? It is going to change. So what I would say is think about what I did to the x to turn, or sorry, think about what I did to the 2x to turn it into an x. I just divided the 2 out, right? And so that's what I'm going to do to 2 pi over 3. We're dividing out the 2. So I'm going to do 2 pi over 3 divided by 2. And that's going to tell me what goes in the rest of the parentheses there, all right? Well, dividing fractions again. So I still recommend you multiply by the reciprocal. So it's actually times 1/2. We see those 2's cross cancel. So we're left with pi over 3. So that's what I'm put right there, pi over 3. Since we just did reverse distributive property, you can a lot of times you can check this step in your head really quick by doing distributive property. So look at this. So if I distribute that 2 back in, 2 times x, isn't that 2x? Yes. And then 2 times pi over 3, is that 2 pi over 3? Yes. Okay, so now let's run through our key information here. So for my amplitude, I got 3/4. For the period, I get 2 pi over 2, which is pi again. You'll notice that our k value is 2. Really, if you even look at the original problem, I always said that the k value is what's multiplying by x, so you can see that that's 2. But even when we factor it out, that's still k. And then we have a horizontal shift, which is to the left the left pi over 3. All right, lastly, I want to remind myself of what type of graph from my chart we are drawing here. I'm going to say that we're graphing a positive cosine. I'm going to do a quick reminder here as to what that looks like. Okay, so now I'm ready to draw it for my graph. Now, remember, we have our left shift here is pi over 3, correct? So I actually need to go backwards to negative pi over 3, and that's going to be my starting point. I'm still starting at a high point because we're talking about cosine here. It's just that that starting point got moved to the left by pi over 3. So then I'm going to draw my graph from there. I'm eventually going to have to figure out what that x value is at the end. We'll get to that in a minute. But I would first do the amplitude. So I would just draw a line right here and put 3/4 since that's our amplitude. All right, now what's this point over here? What's this x value over here? Let's figure it out, okay? So just like we did last time, we know that the period length here is pi radians long. And so you always do, to find the last point, you do the starting point plus the period length. In this case, we started with a negative. So that's okay, just write it down as a negative, all right? So we started at negative pi over 3, then we're moving along for pi. So where do we end up? Well, of course, we need a common denominator here. And I get 2 pi over 3 right there. Beautiful. That one wasn't that hard. When we were originally writing these notes, I told Miss Azamora, I was like, that one might be too hard. But now that we've done it, I'm like, yeah. I mean, that's the hardest one we'll do. So if you thought that was kind of hard, then that's actually good news because they're all easier than that. Cool. So the tricky part about this one was that first step when you have the number multiplying inside the parentheses by x, always take that out front, okay? Now, why did we not have to do that on the previous problem? Because it kind of already was, right? You can see they already took the 2 out front. It's done for us. All right. All right, next page right here, we have this is kind of some review. So let's go ahead and do this on page 6. Let's skip this for today, and then we'll do it tomorrow as kind of like a warm-up. How about that? Because I wanna do one of these problems. So now I really like these. I think these are fun because now this is the other way around. And I don't like drawing graphs because, like I said, I'm like not artistic at all. So this one I like better because it's like they give you the graph. All I need to do is write an equation, which I'd always rather do that. So you do have these ones on WebAssign where you actually have to type in the equation. So these ones will not be multiple choice. The pick the graph will be. Okay. All right, so let's kind of go through everything here and I'll explain how you do it. Why don't I do that over here? So we need to find first the y value of the midpoints. And that's going to be your up, down, shift. Whatever is the y value of the midpoints, that's going to be your up, down, shift. So on this one, I would draw like a dashed line right here. It looks like those are the midpoints. You can see these points are equally distant. It goes from there, it goes 4 up and 4 down. So that's why I would call those the midpoints. So those midpoints are at a y value of 0. So that means my up, down, shift is going to be 0 or none. Okay. Next thing I would find, distance from mid to high points. And that's going to be your amplitude. So my amplitude on this one, I could see the distance from my midpoints to my high points. The vertical distance, I would say, is 4. Okay, next up, I would find the period. So the period is the horizontal distance from start to finish. So I'd say the period here is 2 pi. Start at 0, we end at 2 pi. And then your starting point is going to be your horizontal shift. So my horizontal shift here is actually 0 again. I have no horizontal shift. We're starting at the y-axis, right? We didn't move left or right at all. All right. So that's all the info we're looking for. We do need to do a couple more things before we write down our answer. The next thing is, what type of equation is this based on my chart, right? Is it a sine or a cosine? Is it positive or negative? So this one to me looks exactly like the positive sign. So I know my A is going to be positive, and I know I'm going to say sine instead of cosine. And then one last thing we need to figure out, because the up, down shift, amplitude, and horizontal shift are all part of the equation. The amplitude, remember, is A. The horizontal shift, remember, is B. If we have an up, down shift, that's adding or subtracting outside. But the period is not part of the equation, remember, okay? Remember, K is not the period. So we need to take the period, once you find that, and always set it equal to 2 pi over K. And we need to use that to figure out what K is. So it used to be we were plugging in K. Now we're actually plugging in for the period and figuring out what K is. Now, sometimes you can just look at that and you can see what K is using logic. I think on this one, it's very obvious to me that if I want those to be equal, then K would have to equal 1. Is everybody okay with that? Sometimes it's trickier. We'll get into that more tomorrow. And in those cases, you would go ahead and cross multiply. So you'd say 2 pi K equals 2 pi, and you can solve it like that. You can figure out what K is. But a lot of times it's pretty obvious, and I don't think that that's necessary, and I don't want to make you guys do more work than you have to, okay? All right, so now I think we have everything we need. So let's go ahead and write our equation here. I'm going to say y equals, we know the amplitude is 4, and we know it's a positive 4 because the shape of this is the positive graph. Then I know it's a sine instead of a cosine. And next up, I don't have a b value that's adding or subtracting, so I'm not going to write that. I don't have anything adding out back. My k value is 1, so I could write 1x here, but I'm sure you guys know that if it's 1x, you can just write it as x. So there we go. There's my equation. All right. Awesome. Should we look at some memes? Of course. Okay. All right, so let's look at a meme here. So on Friday we did gang signs, right? So there's a guy graffitiing a sign graph, but this is a stop sign. See the stop sign? Starting at the midpoint, going up, and then back down and finishing there, okay? And if some of you are thinking, hey, Mr. Berry, I know you got all these memes for the sine graph, but what about the cosine graph? Do you have a meme for a cosine graph? Who do you think you're talking to? Of course I have a meme for the cosine graph. Look. So this one's starting at the high point and going down and going back up. So if you did the cosine of y function on the hammock, you could call it the cozy function. Get it? The cozy function, because the hammock is cozy, all right? Awesome. All right, so